Hello, Dr. Spalding here. Today we're going to be doing the domain and range of piecewise functions using interval notation. And our indicator here is graph piecewise define functions, including step functions and absolute value functions, and describe their key features. So here we want to find the domain and range of the piecewise function graph below. We're going to write the answer in interval notation using the fewest number of intervals required. So let's start with the domain. The domain is all the possible x values. So as we come from infinity, the x's exist because this arrow means that the graph continues on forever. So we're coming from infinity. There are still x values on our graph, still x values. Now, here's an open circle, but we have this closed circle here at -2. Because the closed circle exists here at an x of -2, then that means that -2 is still a part of our x values. And then we continue. The graph exists for these x values forever. Because of this arrow here, that means the graph continues forever. So the domain goes from -infinity to infinity. -infinity and infinity always use parentheses. Now, for the range. As we come from -infinity on the y, the range is all the possible y values. We don't start until a y value of -7. That's where this lowest part of the graph exists. The graph still exists for these y values. Graph still exists. Graph still exists. And because these ends have arrows and the ends are pointing up, that means that the graph is going to continue up forever. And because there is a closed circle at the y value of -7, instead of an open circle, we're including the y of -7. So we use a bracket, and then we're going to infinity. Let's look at this one. For the domain. So let's come from -infinity. We have this arrow here, which means that the graph continues forever. So we're coming from -infinity. Graph exists. We're talking about the x values. So there's a hole in the graph when x equals 0. So we skip over 0, but immediately after 0, the graph exists. Looking at the x values, the graph exists. Graph exists. And we have an arrow here. That means the graph is continuing forever. So we go to infinity. So for the domain, 0 was the only part, the only x value that was not part of our domain. So we write that as -infinity to 0, but we're not including 0, so we use a parenthesis, union 0 to infinity. And again, not including 0, so we use parenthesis to infinity. Now, for the range, all the possible y values. So because of these arrows, again, the graph is going to continue forever, and it's going in a downward direction, so we know that we can come from -infinity. The graph exists, graph exists, graph exists, graph exists. But then the maximum y value that we see is 6, but not including 6 because of the open circle at 6. That's the highest this graph gets. So the range is -infinity up to 6, not including 6, so we use a parenthesis. Let's take a look at this one. For the domain, looking at the x coordinates, we have these arrows. So we know that the graph is going to continue forever to the left and forever to the right. So we're coming from negative infinity. But then there's a hole in the graph at an x value of -5. So we're going to skip over -5 and pick up immediately after -5 and go to infinity. So for the domain, the x values are negative infinity to -5, not including -5 because there is an open circle there. So use a parenthesis, union -5 with a parenthesis to infinity. Now for the range. You can see that the graph is decreasing here, and there's an arrow here. So that means that the graph is going to go down to infinity. And here the graph is increasing. There's an arrow here. So as x approaches negative infinity, the graph will go up to positive infinity. The y's will go up to positive infinity. So let's talk about the y values. Coming from negative infinity, it exists, until we get to a y value of 7 because of this open circle here. So there's a gap in the graph at a y value of 7, but we pick up immediately after 7 and continue upward to infinity. So the range is negative infinity to 7, union 7 to infinity. Let's take a look at this one. For the domain, all the possible x values. We have this arrow pointing to the left, so we know that the graph is going to go to the left forever. So we are coming from negative infinity. The graph exists, the graph exists, the graph exists, the graph exists, until we get to an x value of 7, because there's an open circle at 7. So the graph doesn't exist at 7. There's also a gap in the graph between 7 and 8. So the graph doesn't exist there, but there's this closed circle at 8. So the graph does exist at an x value of 8. And because we have this arrow, we know that the graph is going to continue forever to the right. So we go from 8 to infinity. The domain is negative infinity to 7, not including 7. So we use a parenthesis because of that open circle at 7. Union 8, including 8 because of the closed circle at 8. So we use a bracket to infinity. Now for the range. So here we see the graph is decreasing. The arrow indicates that it will keep decreasing. So we know that we have y values that go to infinity. So we're coming up from negative infinity. The graph exists. The graph exists. The graph exists. But then we get to this horizontal line when y equals -1. And that is the highest that this graph will ever be. So the range is negative infinity to -1, and we're including -1 because the graph exists at -1, a y of -1. So use a bracket to indicate that that y value of -1 is included. Let's try this one. For the domain, so possible x values. I see this arrow that's pointing to the left. So I know that my x's will go to negative infinity. I see this arrow here, so I know the x's will also go to positive infinity. So coming from negative infinity, the graph exists until we get to -7. There's a closed circle here. So the x value of -7 is included. So we use a bracket with -7. But then there's this big gap in the graph, in the function. We pick up at 6, but not including 6 because of the open circle at 6. We pick up immediately after 6, and the graph exists, and we go to infinity. So to indicate this part, we say union 6 with a parenthesis to indicate that we're not including 6 because of the open circle at 6, and then going to infinity. Now, for the range. The range is all the possible y values. All right, so we don't have any y values down here. We don't see any arrows that are pointing downward, indicating that the graph is going to be going down forever. So if I look at the graph, the lowest y value that we start with is -7. And then the y values jump up here to the second graph at -1. So we need to include this -7 here. So the range starts by going from -7 to -7. And we put brackets around both -7s because we are including -7. The graph exists there. Now we jump up, so union. Now this arrow is going up. So that means the graph is going to increase forever. So as I move up the y's, the graph exists, the graph exists, graph exists, all the way to infinity. And that again was starting at -1 for the y. So union -1 with a bracket because we're including -1 up to infinity. Let's look at this one. For the domain, I see this arrow. So I know that the x values are going to continue to negative infinity. And this arrow lets me know the x values will continue to positive infinity. So I'm coming from negative infinity, graph exists. I'm looking at the x's, and then I stop when I get to -5 because of this open circle here at the x value of -5. So we go from negative infinity to -5, but we're not including -5 because there's an open circle. So that value of x is not included. Then there's this big gap. The next x value we see is at 3. So we go from 3 up to 5, not including 5, because there's an open circle at 5. We pick up immediately after 5, and we continue to infinity. So for this segment, we're including 3 because there's a closed circle here at 3. So we use a bracket with a 3. Then we go to 5, but not including 5 because of the open circle at the x value of 5. Union 5 for the parenthesis, so not including 5 again, up to infinity. Now let's check out the range. So for the range, I'm thinking about the possible y values. I see that this arrow is pointing downward. So I know that I can go down to negative infinity. This arrow is pointing directly to the right. So it's not going to impact our y's. It doesn't mean that our y's are going to go up. The y's would stay directly to the right. So let's take a look. Graph exists. Graph exists. And at the y's, the graph exists. Even though there's an open circle at the point 5, 1, when x is negative 5, we have whenever, not when x is negative 5, when looking at the y value, when y is 1 here, the graph exists. So we go up to the highest y value, which is 2 at this open circle, but we're not including 2 because of the open circle. So the highest the y value gets is right before 2. So we go from negative infinity up to 2, not including 2 for the range. Take a look here. All right, for the domain, I see this arrow is pointing to the left, so I know I can go to negative infinity. This arrow is pointing to the right, so I know I can go to positive infinity. So coming from negative infinity, the graph exists, graph exists. Graph still exists because of this closed circle right here at negative 3. Even though there's an open circle at negative 3, there is a closed circle at negative 3. So this x value of negative 3 does exist. So keep going until we get to 1. There is an open circle at 1. So we're not going to include 1 for the x. We go from negative infinity to 1 with a parenthesis, union, then we pick up immediately after 1, and the graph exists forever to the right. So 1 to infinity, but not including 1, so we use a parenthesis. Now let's check out the range, all the possible y values. So I see this arrow pointing down, so I know that I have infinitely low, infinitely small y values. And this arrow is pointing up, so I know I have infinitely large y values. So I'm going to start from negative infinity. I know the graph exists. Keep coming up. Now there's a hole at 1, 1, but for a y value of 1, the graph exists over here. So the graph still exists. So we keep going without any breaks. Graph is existing, existing, existing. Now there's a gap right here, but this indicates that the graph is going to continue upwards forever. because of that, we keep going all the way to infinity. So the range is negative infinity to infinity. Now for this one, let's talk about the domain. I have this arrow that indicates the graph is going to continue forever to the left. This arrow that indicates the graph is going to continue forever to the right. So I'm going to come from negative infinity on the x-axis, and then I stop at negative 2 because this opens circle at negative 2. So I don't include negative 2. So right now I have negative infinity to negative 2, not including negative 2, so I use a parenthesis. Union, I pick up directly after negative 2, and I go to 1 and stop there for now. There's a closed circle at 1, so I know that 1 is part of my domain. So union negative 2 with a parenthesis, because they're not including negative 2 because of the hole there at negative 2. Up to 1 with a bracket, because we are including the x value of 1, because there's a closed circle here. Then there's this gap in the domain. So we pick up at 5, but not including 5, because this opens circle at 5. So we have a 5, but we use a parenthesis to indicate that we are not including 5. And we keep going forever to infinity. Now for the range. So for the range, I see this arrow pointing up and this arrow pointing up. So I know that I'm going to go up to infinity. But the lowest y value that I see on the graph starts at negative 6 for the y, including negative 6 because this point has a closed circle. I'm going to go up. There's an open circle here at a y value of negative 3, but the graph exists for a y value of negative 3 right here. So we keep going, up, 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 up. There's an open circle for a y value of 6, but we know that the graph is going to keep going up. So the graph does exist for a y value of 6, somewhere over here, and also somewhere over here, because this may do something like this. It also exists for 6 over here. So we're going to keep going up to infinity. So the range is negative 6, including negative 6, up to infinity. We look at this one for the domain, all possible x's. I see this arrow pointing to the left, so I know that the x's will go to negative infinity, and this arrow to the right, pointing to the right, so I know that the x's will go to positive infinity. So I'm coming from negative infinity, but I stop at negative 8 because of this open circle when x is negative 8, and this open circle when x is negative 8. So we're going to skip over negative 8. So we use a parenthesis to indicate that we're not including negative 8. Union, then pick up right after negative 8. The x's exist for the graph until we get to negative 5, because there's an open circle here at negative 5. So we put -5 with a parenthesis to indicate that we're not including -5. Then there's this gap in the x values. So the next x value that we see is -2. And we're including -2 because there is a closed circle here at -2. So that means the point is included. So we do include -2. So we put a bracket with -2. And then keep going. So the graph exists all the way to infinity for the domain. Now for the range. All right. I see this arrow pointing upward. So I know that the y values are going to go up to infinity. This arrow is pointing directly to the right. So that doesn't mean that our y values will go to infinity or -infinity. Here, they're looks like they're approaching 2. So the lowest y value that we see kind of starts here at -5, but not including -5 because there's a hole, an open circle at -5 for the y. As we go up, the graph exists, keeps existing, keeps existing. Now here, there's an open circle at 5, an open circle at 5. But here, there's a closed circle at 5. Because there's a closed circle at the y value of 5, that means that 5 is included in our range and there's no gap. And we said that we know that this is going to keep going up. So we keep going up to infinity. So our range is -5 to infinity, not including -5, because at that y value, there's an open circle or a hole. Now let's check this one out. So let's talk about the domain. I see this arrow is pointing to the left, so I know I'll go to -infinity for the x's. This arrow is pointing right, so I know I'll go to +infinity for the x's. So I'm coming from -infinity, the graph exists, up to the x of -6. And we're including -6 because there's a closed circle at -6. Then looking at the x's, there's a gap in the graph until we get to 0. So I'm going to start at 0, keep going. Now, there's a hole here, an open circle, when x is 2, but up here at 2, 6, there's a closed circle. So that means that the x value of 2 is part of our graph. So we continue. The graph exists for all these x's as we increase to +infinity. Our domain is -infinity to -6, including -6 because of the closed circle, so we use a bracket. Union 0 for the bracket because we're including 0. There's a closed circle there, up to infinity. And now let's do our range. So for the range, I see this arrow pointing upward. So I know that the y values are going to increase to infinity. And I see this arrow pointing downward. So I know that the y values will go down to -infinity. So we're going to start at -infinity, go up, graph exists, graph exists, graph exists. So over here, graph exists for y's of between -1 and 0. Here, going up, the graph exists. There's a hole at 2, 2, but over here, for a y value of 2, the graph exists. So we keep going. And here, we said the graph goes up forever to infinity. You just can't see it on this coordinate plane, but that's what the arrow indicates. So we keep going up to infinity. So there is no gap in the range. The range is -infinity to infinity.